this fourth degree polynomial that's almost factored but not quite. So it turns out when we make this substitution and multiply it by 3, we get something that's close to the second factor. Now notice if we did plus 23 right here, we would have what we wanted. Plus 23x. And again, folks, to try to multiply this thing out and then factor it, maybe there's a way to do it by grouping or something. But notice you could multiply this whole thing out and get a fourth degree polynomial, and maybe there's a way to factor it there, I don't know. But this factorization just kind of begs in a way, because you get this expression, and when you multiply it by 3, you almost get the second factor right here, you see. But if that means you could just add 23x to this 3u substitution, okay? And that's what happens on the very next line. So this is exactly what we just said here. 3u plus 23x is actually equal to this second factor up here, okay? So that's very useful, it turns out, because we can actually convert the original unfactored expression into something that is in factored form, just like this right here. Okay, folks, and again, there's not much to say right here. I just recopied everything. This first part is equal to the u that we wrote down up here initially. The second part is 3u plus 23x right here. And we have minus 8x squared. Now, this still looks a little hopeless, but it turns out that when you multiply this out, it does factor, okay? It does factor, and so we do have a factored form. However, it's not in terms of just x, which we need that to happen, right? So if you subtract 1x from 3u, you actually get, let me just write it down. You would get 3x squared plus 14x. And again, we're just subtracting the x from 15, so you get 3x squared plus 14x. And then we still have the minus 42, right? Okay. So there we go for the first part. In other words, that's exactly what happens. 3u minus x, literally, you just take the like term x away from the like term 15x, and you get 14x right there. Now what's u plus 8x? Well, here's u. U is equal to x squared plus 5x minus 14. And so we can see that all we have to do is add this 8x to this 5, right? And so what you get is, and I think this kind of thing is fairly cool that you can do these kind of substitutions. So you get x squared plus 13x minus 14. So y'all, we have factored the original problem. Is the product of two quadratics. And again, I'd like to know how difficult it would be just to multiply it all out at the beginning, then try to just factor that raw fourth degree, whatever it is, you know. Now, let's take a look though at what the instructions said. The instructions said to completely factor. So if you take a look at this piece right here, this piece on the right, it actually factors also, and I'll just write it down directly underneath it. It does factor to x plus 14 times x plus 1, x minus 1, excuse me. Right, it's tempting to kind of quit because you have factored it, but it's not completely factored until you write it this way. And we can go ahead and recopy this. This is just 3x squared plus 14x minus 42. There we go, ladies and gentlemen. And so it's completely factored, and I'll circle it. And we'll call it good. Thank you for viewing.